Today, we're going to show you how to make your own custom overlays for the Steam Deck in Windows.
Game over.
What's up, guys, and welcome back to Overkill Gaming, your home for high-end gaming, whether it's PC, PS5, or handheld. We got you covered. One question I get often about my Steam Deck Windows gameplay videos and tutorials is, what overlay is that? Where can I find that overlay? Well, good news. You no longer have to ask me where to find a certain overlay, because today we're going to show you how to make your own overlay to use on all games running on Windows on the Steam Deck. These include Battle.net games, Steam games, Epic games, Game Pass games, you name it. If it runs natively on Windows, you can create an overlay to use with it. And it's easier than you might expect. Before we dive in, guys, if you enjoyed today's video, please be sure to leave a like on the video and also consider subscribing so you don't miss out on future videos like this. Lots of great content on this channel for the Steam Deck. We cover tips, tricks, and gameplay performance reviews. You definitely don't want to miss out on any of it. And also check us out on Discord. We have a great community of like-minded gamers, and it's growing by the day. It is also the best place to find help for the things we show in our videos. We do not provide support in the YouTube comment section. Shout out to my buddy Mute, who worked with me on this for the last couple of days so that we could spread this knowledge to the rest of the community. To get started, all we need to do is download a couple of apps. One is RTSS, or Riva Tuna Statistics Server. Try saying that 3 times as fast. You may have seen many of the gaming performance channels on YouTube that show off how well games run on a particular setup. Well, they all use RTSS. This app basically collects technical stats about the hardware to be used in other software. Many of you may already have this if you've downloaded MSI Afterburner, because it comes bundled along with it. For our use, we will not be needing Afterburner, just the RTSS app. The other app you'll need is called HWiNFO, which stands for Hardware Info. This software will be used to feed certain stats about the system to RTSS for the overlay that aren't already available in RTSS. All links will be provided in the description. By now you should have both RTSS and HWiNFO downloaded onto the Steam Deck. We'll now go over some of the preliminary settings for both. First things first, I recommend having it start up with Windows. Next, you want to have Show On-Screen Display toggle to on. Later, we'll show you how to set up a hotkey using Handheld Companion so that you can toggle this on and off with the press of a button. And if you haven't already seen our video on Handheld Companion, the new controller support app for Windows handheld devices that we believe will change everything, we definitely recommend that you watch that video immediately following this. Link will be down in the description. Moving deeper into the settings, we'll click Setup, and the only thing here that I changed was that I have it set to start minimized. Remember that we also have it set to launch with Windows, so when we launch Windows, it's going to automatically run, and it's going to run in the background. Everything else here remains at the default setting. We have the overlay editor and the hotkey handler. We will discuss the overlay handler first, and after we will circle back to the hotkey handler. This is the overlay editor. This is where we design and implement our custom overlay. This right here is the design and the layout of one of the overlays you saw earlier in the intro. We're going to show you how to build an overlay similar to this from scratch. Here's the other overlay that you saw earlier. This is a minimal overlay that includes battery life, CPU and GPU usage, RAM usage, TDP, time remaining, and FPS. Before we can go further, let's quickly discuss HWiNFO. This is a program that you will need to download, but you will not need to install it. It will download 2 versions of the app and a configuration file. We are only really concerned with the version of the app called HWiNFO 64. Once I downloaded and extracted everything, I simply placed it into my documents folder. It's not really important where it's stored, but whether it's running or not. This app has a bunch of different sensors that will record the stats of the hardware on your Steam Deck. These statistics will be plugged into RTSS and then fed to our overlay. You can right-click a sensor or category to either enable or disable a sensor or group of sensors Not everything you see here is required. Next, we'll locate the HWiNFO icon in the bottom right of the screen in the system tray. We're going to right click on it and click Settings. I have it configured to auto start with Windows, and I also have shared memory support enabled. Shared memory is required to share sensor data between HWiNFO and RTSS. If this box isn't checked, RTSS will not receive data from HWiNFO. HWiNFO does mention a 12-hour limit for shared memory functionality, after which it will reset and have to be re-enabled by restarting the app. This limitation can be done away with by upgrading to Pro. I can say that so far this has not been an issue for me, probably because I do not play on my Steam Deck for 12 hours straight. Unless you are one who does, you should not require an upgrade. Now that we've gotten all of that out of the way, let's build our first custom overlay. The way that I do it is by first clicking on the Layers tab at the top and then clicking Add. This will add one layer to the grid. We will then double click on the text and give it a name like CPU. We will then copy and paste this layer and change the name for each copy. This is because we want each layer to inherit the attributes of the first layer. We will go back to the Layers tab and click Copy, and then go back to the Layers tab again and click Paste. This will create a new layer that is a copy of the first layer. We will double click on this new layer and give it a name. We'll call it GPU. We'll repeat the same steps for the third layer, which we will call VRAM. By the way, if you are able to attach a keyboard to the Steam Deck, then you can use Control-C and Control-V to copy and paste and make the process a little easier. That's what we're using to do this, but you don't have to do it. It just makes it a little easier. So we're going to go ahead and rename this to VRAM, repeating the same steps that we did for the first two. We're going to repeat the same process again for the fourth layer, and this one we're going to name RAM. By now you should be able to see the pattern and what we're doing, and you should be able to see just how easy this is. All we're doing is just basically copy and pasting and renaming and creating our overlay for the categories, and then we're going to do the exact same thing on the right side with the values for the categories. For the fifth one here, we're going to name it BAT for battery, and this is going to keep track of our battery usage. And then for the fifth one, this one is going to be FPS, which will keep track of our frames per second. This next part may seem a bit confusing, but it's really actually very simple. The brightness of the screen will make it difficult to see, so I've included screenshots to make it easier to understand what's taking place. To create the right side of our overlay, we will repeat the very first step, which is to create a layer that will later be copied and pasted and modified with a value. Now, in order to assign a value to our new layer, we will need to go to the Data Sources tab to find the CPU usage. We will click on Edit, and we will need to add the data sources from two data providers. Here's a list of data sources that I have already added from the two data providers. You will need to add them and create a list that looks like this before these sources can be used in the overlay. A few of these have been renamed, so I will show you how to find them in the data providers. To add a data source, you will need to click Add at the bottom. That will bring you to this next screen, which is the data provider screen. The two data providers we will import data from are the internal HAL and HWiNFO. For the new layer that we just added, we need the data corresponding to CPU usage. That can be found under internal HAL. To add this to our list of data sources, we simply highlight it and click OK. To add multiple sources from a data provider all at once, we can select the check next to each one and then click OK. Once it shows up in our list of data sources, all we have to do now is plug it into our overlay. And all we have to do to plug it into our overlay is double click on the layer and type in the hypertext box the name of the source in between two percentage signs, like so. That is just to plug it in, but to get it to show correctly, we will need to add an additional percentage sign to show that this number represents a percentage of CPU usage. We will also change the color to white. We will copy this layer to make all of the layers to follow. We'll copy and paste the first layer as our second layer. Then we'll add GPU D3D usage from HWiNFO and plug it into our second layer for our GPU usage. We'll copy and paste our third layer, then add GPU1 memory usage from the internal HAL data provider to our data sources and plug it into our third layer. We'll also need to make sure that the RAM and VRAM data sources are formatted with 1 decimal and has the following formula to convert it to gigabytes. This time, instead of adding an extra percentage sign at the end, we'll add a GB, or if we want to copy SteamOS, we'll add GIB for gigabytes. The rest of the data sources are as follows. For RAM, we will plug in RAM usage found in internal HAL. Enter it the same way we entered VRAM, in between 2 percentage signs followed by GIB. For the battery usage, we will plug in charge level found under HWiNFO, entered in between 2 percentage signs with an extra percentage sign at the end. For the battery time remaining, we're going to enter estimated remaining time in between 2 percentage signs. You can then add MINS after it to denote time in minutes. If you prefer it to show as hours, then we will need to enter a formula in a decimal format. Estimated time is the data source. Units are in hours. Format is 2 decimal. Divide the value by 60 to convert to hours. And that's how we get estimated remaining time to show as hours instead of minutes. The remaining battery time will only update when the unit is unplugged, and it takes roughly 30 to 60 seconds to update once power has been unplugged from the Steam Deck. Now we'll create the last 2 layers, which are the FPS and frame time graph. For FPS, we will use frame rate, which can be found under RTSS and HWiNFO. Enter it in between 2 percentage signs. And for the frame time graph, we will copy and paste a layer and enter the following. And we are basically done. Really, the only thing left to do now is add a hotkey to toggle the overlay on and off. Also, don't forget to save the overlay that you just created. Save it as OVL. That's the overlay file type. If you want to export it for another machine, export it as OVX and import it on the other machine. If we head back to the hotkey handler, we can see here an option to toggle the on-screen display, and I currently have it set to the numpad 9 key. You can set this to whatever you like using the custom hotkey section in Handheld Companion. I have the number 9 key mapped to the L4 button, the trigger on the back of my Steam Deck, so when I press the L4, it reads it as the number 9 key and it toggles my overlay on and off. Last but not least, we'll show the ability to monitor TDP within the overlay. We will also change the TDP using Handheld Companion and see how the overlay reacts to the change. So what we just did here is we have lowered the TDP to 9 watts down from 15. And what you're going to see is the TDP now showing 9 watts. And within 30 to 60 seconds, you're going to see the time remaining increase, showing that we have improved battery life. All right, so as you can see, we have gone from 15 watts down to 9. And you can see we went from around 120 minutes to now 155 minutes of battery life just by lowering the TDP. Well, that's it in a nutshell, guys. I hope you guys enjoyed this video. If you did, leave a like and subscribe for more. Let us know down in the comments if you were able to create your own custom overlay. If you need support or assistance, hit us up in Discord. We'll see you in the next one.
Game over.